Okay, you see on front of you, and I'm holding up in my camera, there's a book called Building Thinking Classrooms, which talks about ways that traditional math teaching can be improved. Because if you've been in a math class, it probably needed improvement. And this first multiplication task is a challenge from the book. You can try it on your own before Thursday. We'll use it as a warm-up on Thursday, but if you've looked at it, then you can show off because maybe you will have figured it out. The challenge involves a vocabulary term of factors. So what are factors? Factors are the numbers that you multiply to get to another number. So 3 and 5 are factors of 15 because 3 times 5 is 15. 1 and 15 are also factors of 15 because you can multiply those to get to 15. And for lots of students, the best way to think about factors is imagine trying to make rectangles with blocks or coins or some other objects. So 1 and 12 are factors of 12. In fact, 1 and the number itself are always factors. You can always make a train or a caterpillar that's just 1 tall and that many sideways. For 12, I could also do 2 and 6 or 3 and 4. So those are all the factors. Can I make 5 a factor of 12? No, if I try and put the blocks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I try and take these 12 things and make a rectangle that's 5 on one side, then it doesn't come out right. So 5 is not a factor. It just doesn't work out to make a nice rectangle. Is 7 a good one? 1, 2, 3, 4, 5. Oops, 6, 7. Nope, that doesn't work out. I don't have enough down here. 7 is not a factor for 12. Make sense? So find both factors of 5. Let's see if you understand. What are 2 numbers that multiply to get 5? Tends to work better if we take that you're making a rectangle and keep it a square. But we can make 5 of them. Can you make a rectangle with those 5 things?
Sorry, are we doing what we were kind of doing with the coins and stuff, like doing the 1 and then the 5 instead of the numbers?
Yeah, so the only way to do it is this, like caterpillar or train or whatever you want to call it. So make a train.
I was trying to figure out how to just put a 1 times 5. I didn't, but if we're doing it that way, like we did with the coins.
Yeah, you can. You can do 1 times 5.
Okay.
I know that I write easier because I have the pen, but you don't. But there is our shape, right? It is 1 tall and 5 long. And that's the only rectangle I can make with the 5 blocks. What about if we had 25 blocks? Well, let's do a different color. was 10. Did I just take away? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then. Oops. Come on, thing. So here will be 20. 1, 2, and then 5 more. How could we arrange those in a rectangle? What are numbers that multiply to be 25? One will work. What goes with 1?
Or 25?
25. I'm not sure it will fit on the board, but we could make the long caterpillar where we just lined up all of these. It's going to run off the edge if I try, but it would be 1 tall and 25 wide. So that works. What other rectangle can I make with these blocks? What other numbers multiply to get to be 25?
5 by 5.
5 by 5. So 1, 5, and 25 are the 3 factors. You're all good. No one's helping me. Oh, did I not copy them enough? There you go. Okay, last 6. 6 has 4 factors. What are some of the factors of 6? Copy the blocks if you want to make different rectangles. Yes, 1 times 6 will work. What's another way to use 6 blocks to make a rectangle? Perfect. Everyone okay with factors then? At least for little numbers. Do bigger numbers always have more factors? No, 25 is much bigger than 6, but 6 has 4 factors and 25 only had 3. So here is the warm-up problem for next class. There are 12 envelopes. They're labeled from 1 to 12. And inside, each has that much money. You want to get as much money as possible. The trick is that every time you get an envelope, should we have the left or the right basket? I want to label them, which is our money.
Left.
Left, okay, this is our money. Then the taxman gets all the factors. So if we were to be greedy and say, I want 12, then the taxman would get 1 because of 1 times 12. the tax man would get 2 and 6 because 2 times 6 makes 12. And the tax man would also get 3 and 4 because 3 times 4 is 12. So that looked like a good start for us, but the tax man got most of the envelopes, or at least a whole bunch of them. So maybe 12 isn't the best thing to start with. If you are very clever, you might notice that sometimes you can take an envelope and the tax man doesn't have any choices left. For example, if you took 6, then the tax man could do 1 because of 6 times 1. And the tax man can do 2 and 3, because 2 times 3 is 6. And then for your next envelope, you could take 9. And there are factors of 9, like the 1, but that's already been claimed. And the 3, because 3 times 3 is 9, but that's already been claimed. So the rule is you're not allowed to take the 9. The tax man has to get something, or you will be arrested for avoiding taxes. So when you pick an envelope, you can pick any envelope you want, but you have to pick one that lets the tax man claim at least one envelope also. At the end of the game, anything that you can't take, the tax man gets. So how much can you get? That makes sense as a challenge. So if you have time, fiddle with this before Tuesday's class, and then you can get a head start and look real smart in the warm-up problem because you've already worked on this. The discussion thing, which we'll talk about after next class, is advice on how to make math classes better, some of which we can do in Zoom and some of which we can't, but mostly this will be our one. Okay, now that we have done factors, we can play the factor game. So I will put this back in the text chat and switch to a different recording.